The universe looks bright, but most of it is hidden. Beneath the stars lies a secret world, dark matter and dark energy, silent forces shaping everything we see. Tonight, we travel into that unseen realm, where gravity whispers and light dares not go. Chapter 1. Dark matter isn't dark because it hides in shadows. It's invisible because it doesn't interact with light. Scientists only know it exists because galaxies spin too fast without it. Something unseen holds everything together, a silent architect of the cosmos. Without dark matter, galaxies would fly apart like sparks in the wind. Chapter 2. Imagine the universe as a giant web. Galaxies are beads, and dark matter is the invisible thread. Computer simulations show this cosmic web stretching across billions of light years. Where threads cross, galaxies form. Where the web is empty, space itself feels hollow. A cosmic desert shaped by gravity's invisible hand. Chapter 3. Dark energy is even stranger. While dark matter holds things together, dark energy tears them apart. It pushes the universe to expand faster and faster. Think of it as cosmic anti-gravity, a force stretching space-time like rubber. One day, it might pull galaxies so far apart that stars vanish into endless black silence. Chapter 4. The universe is mostly nothing. 68% dark energy, 27% dark matter, and only 5% visible stuff. That means everything we've ever seen, stars, planets, people, are just a thin frosting on an invisible cosmic cake. The real universe hides beneath what light can reveal. Chapter 5. We can't touch dark matter, but we can feel its pull. In the 1930s, Fritz Zwicky noticed galaxies moving too fast to stay bound by visible mass alone. He called the missing mass dunkle materia. It was the first hint that most of the universe hides in plain sight. Unseen, yet undeniable. Chapter 6. If dark matter were gone, galaxies would unravel. Stars would drift apart, cosmic structure collapsing into chaos. It's the glue of the universe, not made of atoms, but of mystery. Some think it's made of particles called WIMPs. Others think it's something entirely new, rewriting physics itself. Chapter 7. In the Milky Way, dark matter forms a vast halo surrounding every star. Our solar system swims through it like a ship crossing an invisible sea. Detectors deep underground listen for whispers of collisions between dark matter and normal matter, faint signals that could rewrite our understanding of existence. Chapter 8. The Bullet Cluster shows dark matter's shadow. When two galaxy clusters collided, normal matter slowed down, but invisible matter kept going. Astronomers saw its gravitational footprint bending light, proof that something unseen was there, passing through space untouched by fire or friction. Chapter 9. Dark energy wasn't discovered in a lab. It was seen in the stars. Distant supernova appeared dimmer than expected, revealing that the universe isn't slowing down, but accelerating. It shocked physicists. Gravity should pull things together, not push them apart. Something strange was rewriting cosmic destiny. Chapter 10. Einstein once added a cosmological constant to his equations to keep the universe stable. Later, he called it his greatest mistake. But today, scientists believe that constant might actually describe dark energy, a quiet pressure built into space-time itself, pushing the universe outward with unstoppable calm. Chapter 11. If dark energy keeps accelerating expansion, galaxies billions of years from now will vanish from view. The night sky will grow empty. Future astronomers may never. Chapter 12. The Large Hadron Collider hunts for dark matter by smashing particles together mere light speed. Scientists hope for traces of unseen energy, tiny echoes from the invisible world. But so far, nothing. The silence deepens the mystery. Maybe dark matter isn't made of particles at all. Maybe it's something else entirely. Chapter 13. Some theories suggest dark matter could be primordial black holes, ancient relics from the Big Bang, scattered like ghosts across space. Others point to axions, feather-light particles drifting through everything. Every idea sounds impossible until the universe proves otherwise. Science, after all, thrives on the unknown. Chapter 14. Gravitational lensing lets us see the unseen. Light bends when it passes near massive objects, revealing where invisible matter hides. Astronomers map this bending, like detectives tracing shadows. Each distortion, each curve of light, paints the silent shape of the universe's hidden skeleton. Chapter 15. In the early universe, dark matter helped form the first galaxies. It acted like scaffolding, pulling hydrogen and helium into dense knots that ignited as stars. Without it, the universe might still be a cold, diffuse cloud. No stars, no planets, no you, no me. Chapter 16. Even though we call it dark, dark matter might not be entirely black. Some theories say it could emit faint radiation or interact weakly with itself. That means somewhere out there, invisible storms could be raging, unseen forces colliding in total silence, shaping everything we know. Chapter 17. The structure of reality isn't solid. It's energy, vibration, and probability. What feels like matter is mostly empty space held together by invisible forces. Quantum fields ripple beneath everything, like a hidden ocean where particles are just waves rising and fading in the vast sea of existence. Chapter 18. Scientists believe that 380,000 years after the Big Bang, light finally broke free, the cosmic microwave background. But beneath that glow lies dark matter's first imprint, shaping the universe's earliest structures. It's like finding ancient fingerprints pressed into the very fabric of space-time. Chapter 19. Dark energy might not be constant. It could change over time, growing stronger or weaker as the universe evolves. If it grows stronger, the universe could end in a big rip, tearing galaxies, atoms, even space-time itself apart. The cosmos could end not with a bang, but with a stretch. Chapter 20. Despite all the theories, dark matter and dark energy remain invisible puzzles. Yet their effects are everywhere. The universe's expansion, galaxy formation, even the rhythm of cosmic history all dance to their hidden tune. The unseen dominates reality, quietly shaping the story of everything. Chapter 24. In the quantum realm, particles flicker in and out of existence. Some scientists wonder if dark energy comes from these constant fluctuations, vacuum energy filling space itself. Every cubic inch of nothing may hum with invisible power, a sea of energy pushing the universe apart. Chapter 25. Dark matter might pass through us every second. Trillions of particles could be streaming through your body right now, unnoticed. Detectors buried deep in mountains wait for one to strike an atom, just once. That single spark could prove the invisible is real, rewriting what we know about matter itself. Chapter 26. Simulations of the universe show a cosmic skeleton, filaments of dark matter connecting clusters of galaxies. Between them lie vast voids, empty regions where matter is scarce. The universe, on its grandest scale, looks like a living organism. A web of light and darkness breathing across eternity. Chapter 27. Einstein's relativity explains how gravity bends space and time. But dark matter adds another layer, invisible mass, bending reality even more. Every beam of light you see is slightly curved by unseen hands. Every starlit sky is shaped by gravity's hidden architecture. The universe is a sculpture carved by shadows. Chapter 28. Some experiments use liquid xenon, cooled to near absolute zero, waiting for dark matter collisions. It's like listening for a single raindrop in a hurricane. Near silence, total patience. Years can pass without a signal, yet every physicist waits, believing one faint flash could reveal the universe's secret half. Chapter 29. Not all scientists agree dark matter exists. Some propose modified gravity, that our equations are incomplete, not our universe. Maybe space bends differently on cosmic scales. Maybe the laws we trust are just local truths. The debate itself shows science's beauty, always questioning, never finished. Chapter 30. If dark matter has its own particles, it might also form stars. Dark stars powered not by fusion, but by dark interactions. They wouldn't shine, but they'd have mass, gravity, and structure. Somewhere in the cosmic dark, entire invisible worlds could exist, unseen, but just as real. Chapter 31. The universe's first stars were born in dark matter clouds. These invisible halos gathered gas until nuclear fire ignited. Without dark matter's pull, it couldn't exist. Those first lights might never have formed. Every sunrise. Chapter 33. Astronomers can map dark matter using galaxy clusters. They observe how light from distant galaxies bends around them. The greater the distortion, the more dark matter is there. These cosmic maps reveal invisible mountains and valleys, a hidden landscape beneath the universe's glowing surface. Chapter 34. Our galaxy moves through space at hundreds of kilometers per second, cutting through a sea of dark matter. If we could see it, it would look like a fog of invisible particles streaming around us. Every star, every planet drifts through this unseen ocean, guided by gravity alone. Chapter 35. Some think dark energy is linked to the fate of time itself. As expansion accelerates, distant events may slip beyond our cosmic horizon, gone forever. The future becomes unreachable, light stretched so far it fades into silence. The universe could slowly erase its own story. Chapter 36. The Planck satellite mapped the cosmic microwave background, the oldest light in the universe. Hidden within its faint ripples are clues about dark matter's role in shaping everything. Those patterns are fossils of gravity's first whispers, written when the cosmos was younger than 1,000,000 years. Chapter 37. Neutrinos once seemed like dark matter candidates, ghost-like particles that barely interact. But they move too fast to form galaxies. Still, their discovery taught scientists how invisible particles shape the universe. Every failure refines the search, narrowing the path toward the truth hiding in the dark. Chapter 38. Gravity is the language of the cosmos, and dark matter speaks it fluently. Even without light, its pull reveals its story. Every cluster, every orbit, every bent ray of starlight is a sentence in the universe's hidden script, a language written not in words, but in motion. Chapter 39. Quantum mechanics and relativity don't fully agree, yet both shape the search for dark matter and energy. Somewhere between the smallest particles and the largest galaxies lies the answer, a bridge between two worlds. Solving it could reveal not just what the universe is, but why it exists at all. Chapter 40. Dark energy could be part of the quantum vacuum, energy woven into the structure of space itself. Every moment, particles appear and vanish in this vacuum sea. Their tiny ripples might create a gentle pressure, pushing galaxies apart. The nothingness around us might be the most powerful something ever known. Chapter 41. Every second, the universe grows by millions of kilometers. Galaxies don't move through space. Space itself stretches between them. That's the power of dark energy. It's not a wind or a wave, but an expansion of reality itself. An endless unfolding that no force seems able to stop. Chapter 39. Quantum mechanics and relativity don't fully agree, yet both shape the search for dark matter and energy. Somewhere between the smallest particles and the largest galaxies lies the answer, a bridge between two worlds. Solving it could reveal not just what the universe is, but why it exists at all. Chapter 40. Dark energy could be part of the quantum vacuum, energy woven into the structure of space itself, every moment. Particles appear and vanish in this vacuum sea. Their tiny ripples might create a gentle pressure, pushing galaxies apart. The nothingness around us might be the most powerful something ever known. Chapter 41. Every second, the universe grows by millions of kilometers. Galaxies don't move through space. Space itself stretches between them. That's the power of dark energy. It's not a wind or a wave, but an expansion of reality itself. An endless unfolding that no force seems able to stop. Chapter 42. Endless unfolding that no force seems able to stop. Chapter 42. Some theories suggest dark matter might form filaments connecting galaxies like veins in a body. Through these cosmic arteries, matter flows, feeding galaxies with gas and energy. If the universe were alive, dark matter would be its circulatory system, invisible, vital, and endlessly vast. Chapter 43. Scientists once thought the universe might slow down and collapse in a big crunch. But dark energy flipped that idea. Instead of collapsing, the universe accelerates outward. Every moment carries galaxies farther apart, rewriting cosmic destiny from eternal return to eternal expansion. A universe forever stretching into mystery. Chapter 44. Not all dark matter is the same. Some could be cold, moving slowly and forming galaxies. Some could be warm or hot, zipping through space and smoothing out structures. The temperature of the unseen decides how the visible world forms. A reminder that even the invisible has flavor. Chapter 45. The deeper scientists look into space, the more they look back in time. Light takes billions of years to reach us, carrying ancient stories of dark matter's work. Telescopes like James Webb now read those cosmic memories, capturing the shadows of the invisible shaping the first stars. Chapter 46. dark matter may form clumps within galaxies called subhalos, invisible satellites orbiting unseen. These hidden structures tug on stars and gas, subtly altering their motion. It's a reminder that even the calmest skies are ruled by silent forces, choreographing the universe's dance from the shadows. Chapter 47. Cosmic inflation, the universe's rapid birth expansion, might connect to dark energy. Both stretch space itself. The difference is scale. Inflation was explosive. Dark energy is patient. One began the universe, the other sustains it. Expansion is not chaos, but the heartbeat of creation itself. Chapter 48. We may never see dark matter directly, but we can feel its fingerprints in every galactic map. Its presence sculpts the cosmos like wind shapes dunes, unseen but undeniable. The visible universe is only the trace of a greater pattern, a whisper from the dark that built everything we know. Chapter 49. Dark matter could interact through gravity alone, explaining why it passes through stars, planets, even us without slowing. It's not ghostly by choice. It simply obeys different rules. In a universe built from interactions, dark matter is the quiet one, shaping everything by staying unseen. Chapter 50. If we could see dark matter, the night sky would glow with vast, invisible halos, filaments, and bridges connecting galaxies. The universe would look like a spiderweb of light and shadow, alive and interconnected. Our world is just one bright node in a cosmic structure far beyond imagination. Chapter 51. Dark energy might not be a force at all, but a property of space itself. As the universe expands, there's more space and more of this energy. It's like a cosmic interest rate, compounding forever. The more space grows, the faster it expands, an endless loop written into existence. Chapter 52. Astronomers once thought they could explain everything with visible stars and gas, but when they measured galaxies' motions, the math refused to work. Something massive, unseen, was holding them together. That realization reshaped physics forever. A silent reminder that what we can't see often matters most. Chapter 53. The idea of missing mass led to decades of experiments underground, in space, and beneath mountains. Detectors wait in stillness, shielded from radiation and noise, hoping for one faint flicker of contact. It's the quietest search in science, a conversation with the invisible. Chapter 54. Dark matter halos aren't static. They collide, merge, and twist. When galaxies collide, their dark halos interact too, shaping the aftermath. Cosmic violence unfolds in silence, unseen waves of gravity rippling through invisible seas, rewriting the architecture of everything from galaxy clusters to cosmic voids. Chapter 55. The universe's expansion means that light from distant galaxies stretches, becoming redder. It's called redshift. And it's how scientists measure the pull of dark energy. The farther the galaxy, the faster it recedes. Space stretching the light itself, a silent echo of cosmic acceleration. Chapter 56. Physicists sometimes call dark energy the fifth force. It's not gravity, electromagnetism, or the nuclear forces we know. It's something else entirely, woven into the geometry of the universe. Every atom, every star, every breath of space hums with its quiet, unstoppable expansion. Chapter 57. Some think dark matter might decay, slowly transforming into lighter particles over billions of years. If true, galaxies could eventually lose mass, changing their shape. The night sky billions of years from now might look softer, dimmer, as the invisible scaffolding quietly fades away. Chapter 58. When two neutron stars collide, they release gravitational waves, ripples in space-time itself. Some scientists wonder if dark matter could make similar waves, invisible tremors in the cosmic sea. If we could detect them, we might finally hear the rhythm of the universe's hidden half. Chapter 59. The search for dark matter unites physics, astronomy, and cosmology. Every experiment, every telescope, every simulation builds a piece of the puzzle. The mystery connects galaxies and atoms alike, proof that the universe is one vast story, told in both light and shadow. Chapter 60. Dark matter might cluster around black holes, feeding their growth. In return, black holes could reveal clues about dark matter through their gravitational effects. It's a cosmic partnership between two great mysteries, one devouring light, the other never touching it, yet both shaping the same destiny. Chapter 61. At the universe's birth, dark matter didn't shine, but it pulled. That gravitational pull shaped everything that came after. The first stars, galaxies, and clusters. It was the silent architect of structure, turning chaos into order long before light ever existed. Chapter 62. Astronomers use weak gravitational lensing to map dark matter. Tiny distortions in the light from distant galaxies reveal the unseen mass between us and them. Each distorted image is a clue, like ripples on water, showing the shape of the wind. Chapter 63. Some believe dark matter could be made of sterile neutrinos, a hidden form of an already ghost-like particle. If found, it would bridge the gap between known physics and the unknown. Every new particle discovered expands our view of what reality truly means. Chapter 64. Dark energy could someday fade or reverse. If it weakens, gravity might reclaim dominance, pulling everything back together in a big crunch. If it strengthens, the cosmos could end in a big rip. The universe's fate depends on the behavior of something we can't even see. Chapter 65. Galactic collisions show us dark matter in motion. When clusters merge, hot gas glows, but the real mass, the dark matter, sails through untouched. It's the ultimate test of invisibility, proof that not all matter plays by the same rules of light. Chapter 66. Dark matter halos formed early, before stars existed. They were like invisible scaffolds waiting to be filled. Hydrogen and helium gathered within them, igniting the first cosmic fires. The visible universe grew around invisible bones, built on foundations of shadow. Chapter 67. If you compressed all dark matter into visible form, the night sky would blaze brighter than any sunrise. Every space between stars would shimmer with unseen mass. The fact that it doesn't reminds us the universe hides its greatest truths behind perfect silence. Chapter 68. Quantum field theory suggests even empty space has energy. Dark energy might simply be that, the natural hum of nothing. Every point in the vacuum vibrates with potential, a soft tension stretching the universe. Emptiness itself may be what drives everything apart. Chapter 69. Some researchers think dark matter and dark energy are connected, two sides of one phenomenon. One pulls, one pushes, balancing cosmic structure. It's a dance of gravity and expansion, attraction and repulsion, keeping the universe alive through constant tension. Chapter 70. When scientists simulate the universe with dark matter included, galaxies form just as we observe them. When they remove it, structure collapses. It's the simplest proof of all. Without darkness, the cosmos doesn't work. The invisible is not a theory, it's the framework of reality. Chapter 71. Dark matter doesn't clump on small scales like stars do. Its particles move too quickly, spreading out instead of condensing. That's why we don't see dark planets or dark stars. It shapes galaxies, not worlds, a force that builds the grand, not the small. Chapter 72. Cosmic background radiation shows faint patterns, tiny temperature differences left from the Big Bang. Those patterns trace where dark matter was densest, guiding the first galaxies. Every pixel of that ancient light carries a message from the universe's hidden structure. Chapter 73. Some dark matter models predict particles that could annihilate each other, releasing faint gamma rays. Telescopes scan the Milky Way's center, searching for this glow. If found, it would be the universe revealing its invisible heartbeat, light born from darkness itself. Chapter 74. The expansion of space doesn't move galaxies through the universe, it stretches the universe itself. Distant galaxies aren't flying away, the space between them grows. Dark energy drives that stretch, rewriting distance, time, and the meaning of far with every passing moment. Chapter 75. In the early 2000s, astronomers measured supernova and realized the expansion was speeding up. That discovery changed everything. The cosmos wasn't coasting, it was accelerating. That single revelation turned the universe from predictable clockwork into a living mystery. Chapter 76. Dark matter keeps galaxies together, but it also allows them to collide. Over billions of years, clusters merge, stars weave new patterns, and dark halos blend. The universe builds through destruction, creation through collision, all guided by invisible hands. Chapter 77. If we could see dark matter, the Milky Way would look like a glowing sphere, our familiar spiral floating in its heart. Every orbiting star, every drifting comet, every motion traces the curve of that unseen halo, our galaxy's invisible guardian. Chapter 78. Dark energy may influence time itself. As the universe accelerates, the flow of time changes subtly across space. Some regions may age faster, others slower. The expansion of the cosmos isn't just movement, it could be time stretching along with space. Chapter 79. In physics, symmetry rules everything. Some theories suggest dark matter exists to restore broken symmetry, a missing balance in nature's equations. The universe may hide half its ingredients simply to stay perfectly stable, beauty preserved through invisibility. Chapter 80. One day, galaxies beyond our local group will drift so far we'll never see them again. Light won't reach us. Future beings may think the Milky Way is the entire universe. That's the power of dark energy, slowly erasing the cosmic past from sight. Chapter 81. Dark matter doesn't emit, absorb, or reflect light, but it still bends it. That bending, called gravitational lensing, turns space into a natural telescope. Through it, scientists see galaxies behind galaxies, light curved by invisible mass, a cosmic illusion sculpted by gravity's ghost. Chapter 82. Every particle in existence vibrates with energy, even in absolute stillness. Dark energy might arise from these quantum tremors, the restless vacuum that refuses to be empty. Space itself hums faintly with potential, the quiet song of creation that never ends. Chapter 83. Astronomers build massive surveys, scanning millions of galaxies to trace the large-scale structure of the universe. Patterns emerge, filaments, walls, and voids. Each one matches where dark matter is densest. The universe isn't random. It's a vast design shaped by invisible order. Chapter 84. Dark matter might explain why galaxies spin the way they do. Without it, stars near the edges should drift away. But they don't. The invisible mass anchors them, like a hidden hand keeping the galaxy whole, holding every star in its silent embrace. Chapter 85. Black holes distort space, but dark matter doesn't. It slips through everything untouched. The two are opposites. One devours, the other passes through. Yet both are invisible forces defining cosmic architecture, the yin and yang of the universe's hidden geometry. Chapter 86. Some theories suggest dark energy could eventually weaken, halting cosmic acceleration. Expansion would slow, galaxies might drift closer again, and time could loop. Maybe the universe breathes, expanding and contracting in endless cycles, like a cosmic heartbeat repeating across eternity. Chapter 87. Astronomers use computer simulations to recreate billions of years of cosmic evolution. When they add dark matter and dark energy, the result mirrors reality. When they remove them, everything falls apart. The invisible isn't optional. It's the backbone of creation itself. Chapter 88. The search for dark matter has led scientists to build detectors in abandoned mines, deep under mountains, and even beneath ice, shielded from cosmic rays. They wait in silence, hoping for one collision that could light up a detector. Proof that darkness isn't empty. Chapter 89. Some cosmic rays may come from dark matter decays, releasing high-energy particles into space. If confirmed, these signals could reveal the nature of the invisible. Each burst of radiation might be a clue, the universe whispering secrets through ancient light. Chapter 90. Dark matter may not only shape galaxies, it might influence life itself. By stabilizing the Milky Way's orbit and structure, it keeps our solar system safe from chaos. Every breath we take, every night we see stars, exists because of an unseen balance beyond imagination. Chapter 91. In the voids between galaxies, dark matter is thin, almost absent. These empty regions are vast deserts of nothingness, hundreds of millions of light years wide. Yet even there, its faint pull shapes the borders of existence, the invisible fences of the cosmic landscape. Chapter 92. Some scientists propose dark matter might consist of ultralight particles, forming vast quantum waves across galaxies. If true, space itself ripples like a slow ocean. Each wave could stretch light, bend motion, and shape stars, gravity guided by the rhythm of quantum music. Chapter 93. The Milky Way's satellite galaxies orbit in strange organized planes, patterns normal matter alone can't explain. Dark matter could be the hidden hand aligning them. Even the smallest cosmic motions seem to follow the geometry of the unseen. Chapter 94. Dark energy remains one of physics' deepest puzzles. It doesn't fit neatly into quantum theory or relativity. It's like the universe's code has a hidden line we can't read. A mysterious variable rewriting reality from within its OET equations. Chapter 95. When dark matter passes through Earth, it doesn't collide or slow. It moves straight through mountains, oceans, and skin, indifferent, invisible, unstoppable. Every moment, countless unseen particles pass through you, quiet proof that we live within the unseen fabric of the cosmos. Chapter 96. Galactic clusters show the scale of the invisible. Each contains hundreds of galaxies bound by massive halos of dark matter. Between them, gravity weaves a cosmic net, a silent architecture stretching beyond sight. The universe is a cathedral built from what we cannot see. Chapter 97. Some physicists wonder if dark energy might emerge from extra dimensions. Perhaps space has hidden layers, and what we feel as expansion is gravity leaking through them. If true, the cosmos could be more than vast. It could be multi-dimensional, a shadow of a deeper reality. Chapter 98. Even though dark matter can't be seen, its gravity influences how galaxies form and merge. It decides where stars ignite and where voids stay empty. Every flicker of starlight owes its shape to something that never shines, the unseen sculptor of cosmic fire. Chapter 99. In the end, dark matter and dark energy remind us that 95% of the universe is hidden. Our world, our stars, everything we know, just the visible tip of an unseen ocean. Reality is larger, quieter, and far more mysterious than light can show. Chapter 100. Perhaps the universe hides its secrets, not to be cruel, but to invite discovery. Dark matter and dark energy are reminders that truth isn't always visible. The cosmos whispers through gravity, through silence, through wonder, asking us to keep looking into the dark. The deeper we look, the more we realize how little we know. Darkness isn't emptiness. It's the foundation of reality itself. Somewhere in the silence between galaxies, the universe keeps its greatest truth, waiting for us to find it.